Alright, everybody, welcome back. We are beginning, or continuing, rather, in our study of Server Plus, and we're in section 1, which is about server hardware basics. So, we got server hardware basics. Oh, shoot. Server hardware basics. We have server form factors. And so under form factors, we're talking about like a lot of different physical sizes and stuff. So we're going to hear about tower servers, blade servers, rack mount servers, tower, blade, rack mount, got racks, sliding rails, we got blade enclosures, yeah. So we're going to learn about that kind of stuff, and then we're going to talk about server CPUs. And what do we care about server CPUs? We're going to dig more into single servers often have multiple CPUs. They often have multiple CPUs plugged into sockets on the motherboard. So that's why in many cases you wouldn't want to just take a regular computer and turn it into a server, because a computer built to be a server is going to have multiple CPUs, not just one. Each CPU chip consists of one or more cores. Core has the same functionality as a physical CPU. Multiple cores can be embedded on a single CPU chip. They use high speed, L1, L2, L3 cache memory. What do we care about that? For data instruction, for data and instructions to speed up processing, 4 GHz CPU slows down when data needs to get on a bus to get to a different component in the server. For example, it will slow down to 600 MHz. Desktops and servers commonly use the more powerful complex instruction set computing processors. What is that? Okay. Mobile and consumer electronics need less power. Okay, so desktops and servers use the more commonly CISC processors. Mobile and consumer electronics need less power, and which means less heat and cooling required, so they tend to use reduced instruction set computing processors. Oh, interesting. RISC. Reduced. Well, that's pretty interesting to know, isn't it? That's good to hear. All right. Well, let's go ahead and clone this page. Okay, and we'll make this page 2. Hello, Crunchy. It's my cat. Continuing with server hardware basics, we have server memory. What do we care about server memory? Well, first off, we don't. Well, that's not true. We do care about server memory. So, scaling a database server to support larger data sets means adding RAM. Virtual servers can be configured to use more RAM as needed. And that's pretty true. I don't know if you've... I made a bunch of videos where I was playing with virtual machines before. And if you're familiar with them, when you build the virtual machine, you can share a portion of your computer's RAM with the virtual machine, up to a certain amount. And but it's elastic, right? So like if you want to boot up the machine with 4 gigs of RAM this time and 6 gigs of RAM next time or whatever, just you can set it up like that. It's actually pretty cool to mess with, especially if you're into this kind of stuff. It's really worth checking out. So, but we're talking about server memory. Extra RAM becomes available from other virtual servers on the same underlying principle. The host the host has enough spare RAM at the time, right? So it's just got to be available. But if you're running like if we were running 4 different virtual machines on top of Ubuntu, of course, I would need to have enough RAM in the host computer to support all 5 of those, because it would be the Ubuntu running on the hardware, and then also the 4 virtual machines. So I could probably do it with about 16 gigs of RAM, but it would be stretching everything really thin, and pretty much anything would most likely turn into a race condition if I tried to run like 4 or more operating systems. What is that? Okay. Oh, that's Crunchy. He's over there in the corner. So if I tried to run 4 or more operating systems on 16 gigs of RAM, everything would pretty much turn into a race condition. Everything would be fighting for resources. So, everything has limits. But that's the beauty of virtuality, is like, if I had 32 gigs of RAM in there, I could be running like 8 different computers at one time, and that's exactly why we do it, because I don't need 8 physical computers. I could use, 1 to run 8. And so anyway, we need scaling is important. So let's talk about scaling. We have SRAM, which is static. We have DRAM, which is dynamic. And dynamis. And what is the difference, you might ask? Well, that's a good question. Let's read about it. Memory is either static or dynamic. SRAM is used in smaller amounts and is faster than DRAM. SRAM is used in smaller amounts. We'll have to figure out what that means. Okay, DRAM. DRAM requires a constant refresh of electricity. All right. Well, that's pretty cool. SRAM is used for L1, L2, and L3 CPU cache memory. Oh, hey, let's bump this down here. Used for, you know what? I totally forgot. I forgot about this stuff from A+. L1, L2, and L3 CPU cache memory. And then it goes on to say not the main system memory. Okay, so main system is DRAM. Did you know that? I didn't know that. But well, I mean, I should have known that. I acknowledge the fact that I'm responsible for that, but I got fucking stacks of books on this stuff. I mean, I can look it up, right? And that's kind of the point. You need to know where to find it. So this is where we found that. Okay, various types of RAM chips. Which ones will work in your specific hardware? So let's indent that. Let's indent that. Vasarius. Let's talk about various type. Various. Can't even spell today. You know, I was thinking of various Rucker. God. All right, there we go. Okay, so you need to know about the various types of RAM chips and the ones that will work in your specific hardware. That's true. You know, if you got DDR4 and whatever. Some servers will accept only double data rate 3. Others use DDR4. Okay? So memory chips might also have to be added in pairs for efficient use by servers, motherboards, multiple CPU sockets. Modern motherboards have color-coded chip sockets. That's pretty cool to know. So we're going to talk about DDR3, DDR4, and so on and so on. There are more. Many servers use memory chips that can detect and fix memory corruption known as error correcting code, ECC memory. So I believe these are expensive. I think they use them in places like banks and stuff like that. That's why memory chips from a desktop, even though they might physically fit on the server motherboard, may not work correctly. They're not usually EEC chips. So you wouldn't use EEC chips in a regular build. Let's go ahead and create a new page. Say hello and welcome to everybody who's been jumping in. Let's duplicate this slide. Welcome everybody. I hope you find cybersecurity. Oh wait, this is servers. We're not doing cybersecurity tonight. But I hope you find computers as awesome and riveting as everybody else. Nah, they're pretty cool. The thing is after we sell all of our farmland over and build data centers on it so we can't make food anymore, you know, we'll be slaves to the robot overlords. So you might as well know how to, you know, what we're doing right here is reading the enemy's playbook. We're training. This is training. So, yeah, we're going to get into buses and slots. Now, I don't know if this is the correct spelling of buses. I always like to spell it like that, even though something tells me it's not right either. But anyway, buses and slots, expansion slots. Say you need a 10 gigabit Ethernet card in your physical server All slots are not created equal. Older PCI Express. Let's write that down. PCI Express, which is what? PCIe, we call it? Times 2 card will fit in. A PCIe 2 card will fit and work in a PCIe 16 slot, but it won't work the other way around. So a PCIe times 16, a card for a PCIe times 16 slot will not work in a PCIe times 2 slot. And cards have their own form factor. Some expansion cards fit into a slot. They might fit into a special slot on the motherboard, but the card is too tall, and the back of the case may not fit back on. Expansion cards need a bus to move data into and out of the card. So servers use a variety of buses to move data around the system. That's an important thing to know. Okay. Thinner servers such as rack mounts and blades won't accommodate standard height cards. Standard. You want a standard height. Well, shit. Where did my cursor go? No. Standard Higet. Higet. Oh man, I just butchered that one totally. Yeah. Okay. Get this back under control. Okay, so where did I see that? Let's go back to thinner servers. Okay, won't accommodate, but some rack mount models will allow a daughter card to plug in, which in turn has slots oriented in such a way that standard size. Okay, so some rack mount models will allow a daughter card. Expansion. Oh. Okay, let's just let's do it like that. Okay. Blades get their additional capabilities in such a way that standard such as storage and networking from other components plugged into the blade enclosure. You won't find a blade server with PCI card networks plugged in. Okay, blade servers don't use PCI cards. That's kind of important to remember. So they probably don't, a blade server probably doesn't have storage. It might have a NIC so it can communicate on the network, but it'd probably use some kind of network attached storage, and it like literally just works to, you know, direct traffic or something. I don't know. We'll figure it out. Like direct traffic to it would serve up whatever's on the attached storage. Okay, I think we got all that. So our next thing is virtualization. And it's pretty much one of the biggest reasons we want to make servers in the first place is to run virtual stuff. Virtual servers run as a guest on a host. Okay, or a hypervisor, probably. Some hypervisors will allow virtual guests to access the physical hardware components directly. Now that's a problem when they if you got a hypervisor that allows the guests to access the physical hardware components directly, you could have a VM breakout where people break out of the virtual machine and break into the hypervisor, so we have to be careful about that. Something we learned about in Security Plus. Or VM escape, whatever it's called. Allow virtual guests to access some. Okay, let's make a note of that. Allow virtual. They allow virtual guests to access physical hardware components directly. Components. Okay. Let's see. Others emulate hardware for the guest. Okay. Nice. Okay. Physical multiprocessor system enables each VM to be configured with multiple virtual CPUs, but more virtual CPUs doesn't necessarily mean better performance. This is because the hypervisor can get bogged down finding physical CPU time slots for all of the virtual CPUs. It really depends on what is running within the virtual machine. Sometimes less is more. So we'll learn more about, come on, where's my we got vCPUs, that's a thing, okay. Bumping up the number of vCPUs can also cause another problem, licensing, like if you're running Windows. Many software vendors license their server-based products based on the number of physical or logical processors. Talk to your favorite software vendor to ensure your compliance with their license rules. Ideally, you'll have an automated way to periodically inventory both hardware and software in use on the servers. This is especially useful in a data center. Okay. So we have, and let's see here. Let's do this. Let's start the next page, but I'm gonna take a break for a little bit. Let me see here. Start the next page. Start the next. Damn it. Duplicate slide. There we go. Page 4. Oh, I see what happened there. Okay. Yeah, that makes sense. Okay, now get down here. So this is going to be another thing over here I'm going to fix real quick. That's got to go back here. And that could be back here. That's fine. Okay, so when we come back, we're going to start getting into environmental factors. We're going to continue on, but we'll take a break for now. Thank you everybody for joining, and have a great day. God bless.